All right. So this is a little bit of a mixing up of the kind of regular flow, but I figured it'd be nice to come back in this next meeting and go through the last question that really covers everything we talked about in the last section as kind of just a review after the fact. So let's dive in and kind of recap what we learned all in one question. So we do have a function here just to remind you that this is a function because it does pass that vertical line test. Any vertical line you can draw is only going to touch the graph at one point. And from there, we want to answer all of these questions. So let's go through it. Remember that domain is how far left or how far right the graph goes, or what values of x are allowed to be plugged in and produce the result that you see. Well, there are no open circles anywhere here, so we don't have to worry about that. We then have to worry about these arrows. So this arrow does go left forever. So all x values, all the negatives, and everything in between. And even though this looks like it's increasing very quickly, which it is, it's still moving to the right as it increases. So that makes the domain negative infinity to infinity. Now the range is going to be a little bit trickier to nail down, but remember range is how low does this graph ever go and how high does this graph ever go. And well, it looks like the lowest point this graph goes is going to be right here. And the y value that that graph is at that point is -4. So the lowest value of my range is now bracket -4 because I can touch -4 as a y value, evidently at 5, and that will show up later as we go through this as well. And then how far up do we go? Well, on the left-hand side, we eventually stop growing, but we cover everything from -4 all the way to 21. But look on the right-hand side, not only do we cover everything from -4 to 21, but we also increase forever, so that makes our possible range values go all the way up to infinity. So just because one side is limited, so to speak, doesn't mean the entire function itself isn't limited if the other side increases indefinitely. Okay, x-intercepts. Where do we cross the x-axis? Hopefully you can see those places. We cross the x-axis in two places, and they are x equals 3 and x equals 7, right here. Those are our x-intercepts. All right, well then let's look at what the y-intercept would be, and we've actually said that already. The y-intercept is going to be where y equals 21 is where I cross the y-axis. All right. Up next, things are going to get a little trickier. Where is this graph increasing? So when we ask increasing, we are reading from left to right. I guess we'll put a dot here as well. But we're reading from left to right and asking when is the graph moving up? Well, right now, as I move from left to right, the graph isn't moving at all. It's staying constant. Now, as I move right, my graph is moving down, so I'm decreasing. And then right here at this point, which again, we've already talked about this point being important to our range, but this point is where the graph then starts increasing. So at the x value 5 and then on to infinity forever, that's where my graph is increasing. Now remember, increasing, decreasing, and constant, those should be sub-intervals of your domain. So at some point, we're going to have everything we need to go all the way from negative infinity to infinity, but right now we're at 5 to infinity. All right, a little more quickly, where are we decreasing? Well, we already said it from this value down to here, but remember, we're talking about the domain. We're talking about the x values. When am I decreasing as I move from left to right? And so that would be from 0 to 5 for the x values. All right, oops, sorry, 0 to 5. Well, and now really it's just process of elimination, so to speak. But if I said eventually we're going to cover everything, and we have 5 to infinity, and we have 0 to 5, then it should be obvious where it's constant, but also we can look at the graph and see where it's constant. From negative infinity all the way to 0, that's when the graph is constant. Notice every time we wrote any of these intervals, here, 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 or here, we are always going from least to greatest order, and then using our parentheses or brackets as needed if we're approaching or can be that value. Now also, again, remember when we're splitting up the domain, because 0 is a point where things switch, because 5 is a point where things switch, notice we don't use a square bracket on them because they're a place of change. Okay, Up next, where does my graph have a relative minimum? We should be able to say that really quickly. That's going to be at x equals 5, and that relative minimum is -4. All right, so um, this is the one that I was saying we've called it out multiple times, and it's important. It's this lowest point right here, which was also, again, the bottom of the range of f, was in this case my relative minimum. Up next, they just want to know what my graph is at -2. Sorry, at -2. Well, when x is -2, here we go. Use your vertical line from the vertical line test and ask, where are you right here? Well, I'm at 21. So f of -2 must be 21. All right, up next, we want to know, where is my graph equal to -3? So that's a little bit of a different question, but now it's saying look at the y-axis, find -3, and see where your graph crosses. And I see two places at x equals 4 and at x equals 6. My y value will be -3. So 4 and 6, and we'll separate them by commas. Up next is f even, odd, or neither. Now remember, that's a question of symmetry. Is this graph symmetrical across the y-axis? No. Is my graph symmetric across the origin? Is it a double flip situation? No. So the answer would be neither. All right, so that took a little bit to get through, but I think it was nice to kind of recap this after spending some time away from it and see the whole thing in practice. Up next, let's dive into 2.3, and we should be able to get a pretty good way through before we kind of break for the next video. So for 2.3, we're going to start to talk about lines truly, and we're going to first start off by talking about slope. Now, there are four slopes. There's positive, there's negative. I'm just going to shorthand them. There's 0. Actually, I think I'll call it, um, yeah, why not? We'll say 0, and then we'll say the special one, undefined. And I'll actually just spell that one out. But later on, I'll probably just write it as undef with a dot. Now positive. Now, what we're going to do for all these is we'll say, as we move left to right, and I really hope that you catch the subtlety there, that we're still approaching this with domain and range vocab here. We're saying, as we plug in the furthest left x value and move towards plugging in another further to the right x value, as we scan our vertical line from left to right and we ask, what did I plug in and what did I get? What were my y values doing? Well, for a positive slope, we'll say the line increases. So we've already talked about that before. And then for a negative slope, well, guess what? The line decreases. For a 0 slope, the line is constant. And for undefined, as we move from left to right, it's really just, it doesn't work that way, really. This is and we'll kind of spoil it, it only moves vertically. Okay, now another thing we could say here, just quickly draw, is this. A positive slope, hopefully based on that description, would look like this. A negative slope could maybe look like this. It's definitely a steeper negative, but it's still negative. A 0 slope, of course, would look like this. And that makes an undefined slope look like this. So we've got positives, we've got negatives. Again, don't think that I just didn't draw my vertical line right. That's what this one is. This is a very steep negative slope, but it's still negative. All right. Excuse me. From there, now the question becomes, how can we strictly find slopes between 2 points? And the key there is, in order to form a line, any line, really, as long as you just have 2 points, there's a way to find an equation that connects those 2 points, and there you go. And that also means between any 2 points, there's a way of finding a slope. Now we're going to write out that formula, and that formula looks like this. Hopefully it looks familiar. y2 minus y1 over x2 minus x1. This is your slope formula. Now, also, you've probably informally heard slope as rise over run, and maybe that sounds familiar. Also, we might call this the change in y over change in x, because if you want to know how much something has changed, you subtract them and compare their difference. But with that being said, let's look at these two examples. We'll start this one off here. And well, notice we have 2 points. We have point number 1, point number 2, just to go in order. And so that means, remember, every point has an x value and a y value, an x value and a y value. So this must be x1, this must be y1, because it's from the first point, the first x and y. Then there's the second y value and the second x value and the second y value. So that's x2 and y2. So now I know what to plug in. As I do my slope formula on this first example, I'm going to say my slope is 7, the second y value, minus 5, this 5 right here, because that is the first y value. All that is over this 5 now, because this is the second x value, the x value of the second point, and that must mean I then have minus 4 here. Well, to work this out, we're just going to do simple subtraction here. That's going to be 2 over 1, and well, thankfully 2 over 1 just simplifies to 2. And so, this is definitely a positive slope. And we'll look at what that means on a graph later, but for now we're just going to say, can I identify what the slope is? Up next, let's do the same thing, but a little more quickly. And maybe you already did, but we've got our y2, y1, x2, x1. And so I've got my 3, now watch this, that's y2, minus negative 8, because that's the first y value, y2, 3, minus y1, negative 8. Notice how I wrote that minus negative 8, and we'll deal with what happens there in a second. That's going to be over this 4, because this is the 4 from the second point, minus this 4, this is the x, or that 4 from the first point. And let's see what I get now. I get double negative, so 11 over 0. If you take your calculator and you write 11 over 0, you're going to get error divided by 0, or something's going to show up on your calculator like that. And that's your clue that you just found an undefined slope. So there's your undefined slope. It's what happens when you get 0 on the bottom of a fraction. Now, if this was flipped and it said 0 over 11, guess what? Now that would just be a 0 slope. You can plug 0 in over 11 into your calculator and everything will be fine. But if you plug 11 over 0, again, you'll see an error. Errors mean undefined. So this must be a vertical slope. And honestly, the other way to see these slopes is, make a little axes for yourself and graph them. But we won't do that for sake of time. But I think that'll solidify why this is undefined and why it's vertical if you see the way those two graph. All right, let's write down some equations of lines. One should look very familiar and one's going to be a little new. Now this one is called the slope-intercept form. And, well, it's because m is the slope. And to be really precise, the y-intercept is the point 0, comma b. Or in other words, this value right here is telling you where you will cross on the y-axis. Technically, where you cross is a point, but the y value of that point is the y-intercept. All right, let's look at our next formula then. Our next formula is the point slope form. Now this one you might be less familiar with, but as a mathematician, this is the one we end up using more often in higher level maths. Now what I want to maybe point out, just as a, that's kind of interesting, is if you notice, if I were to take this x minus x1 and divide it over, I just want to say out loud, that would look mysteriously like this slope formula, but the short answer is that's not mysterious, and that's not a coincidence. That's actually where these two are relating to one another. So just be aware of that. That maybe that's a way to memorize the slope and the point slope form. The point slope form is just the slope formula when you move these over and you don't write y2 and x2, you just write y and x. Interesting. Now, what are we going to do with those? Well, let's look at this example. It says find the point slope and slope intercept form of a line. Well, it says start with point slope first, and really, I don't have another choice but to do that. And, well, think about why. What were we given? A slope and a point. So it makes sense that this would be the first one we go to. All right, well, let's use it and see what we get. It'll be y, just y, minus the y value of the point they gave me. Remember, the y value is the second one that's written down, x and y, equals m, my slope, which they told me was 5, times general x minus the x value that was given in the point. Now this is your point slope form, put a box in it, you're done. But now we want to find the slope intercept form. Now, if you think about it, the way we can really get to slope intercept form, let's say it like this, is we have no parentheses, which means we distribute, and we get y by itself by, in this case, adding the 3 over. So let's do those 2 steps, and we're done. So thankfully, we haven't encountered too much trouble yet. When I distribute that 5, I get a 5x, I get a minus 20. And when I add the 3 to the other side, remember it's only going to combine with the term that is a single number, which will give me negative 17. And so now I know that this graph, wherever it is, it's going to cross the y-axis at negative 17, and it's going to have a positive slope of 5. I mean, I guess I knew it had a positive slope of 5, but the fact that it passes through that point is kind of interesting. Let's maybe look at one more, and then we'll break this video, and then we'll look at the graphs and finish up everything in the next one. So we're almost done with this whole chapter. We're doing good. Next, it's the same question or concept, find the point slope and slope intercept. So here we go. Oh wait, this time we don't know the slope, but we know 2 points, and we know how to find the slope from 2 points. So that's kind of a tricky one, is so far right now we don't even have the slope and a point, we just have 2 points. But again, we learned y2 minus y1 over x2. Sorry, I should be like kind of pointing it more. Y2 went here, minus Y1 went here, all over X2, the X value of the second point went right there, minus, and then we have a double negative again, negative 4. All right, let's work that out and see what we get. This is going to be negative 5 over positive 5. We're really lucky we haven't encountered fractions. You probably will on your homework, but now I know what my slope is. Now I haven't answered any of the 2 questions up above. I want to make that clear. We haven't actually gotten the point slope form. We haven't gotten the slope intercept form. We've just figured out what the slope is. In other words, we figured out this piece of information that we then used later in the last problem. Well, so now that I have that, I have a slope, and I've got 2 points to choose from, but why not? Let's just still use the first point, because after all, that's the way the formula goes. So let's get our point slope form next. Point slope. That's going to be y minus the y value of the first point, y minus y1, equals the slope that I just spent a lot of time finding, times x minus the x value of that first point, which again will double negate. At this point, actually, before I put a box around that, I should handle just that double negation. And so there is my point slope form. Usually we don't want like nested parentheses when we write our point slope form. We only want a single set of parentheses. And so then we're almost there. We now just need to distribute and move over the 6. And so I've got y minus 6 equals negative x minus 4. And I just need to add the 6 over, and I now have negative x plus 2. I now know that the slope is negative 1. I now know that the y-intercept is 2. Again, we haven't seen what that looks like on a graph yet, and that's because that's the next video. So I'll see you then.